Graphing y equals the inverse cosine of x, or the arc cosine of x, is similar to graphing the inverse sine. First, we need to make our x's our y's and our y's our x's. So we flip the two columns. We get 1, 0, square root of 3 over 2, pi over 6, 1 over square root of 2, pi over 4, 1/2 pi over 3, 0 pi over 2, negative 1 over square root of 2, 3 pi over 4, negative 1 pi, negative 1 over square root of 2, 5 pi over 4, 0, 3 pi over 2, 1 over square root of 2, 7 pi over 4, 1, 2 pi. So again, same problem we had with the inverse sine, where we have values of x that match up to two different y's, making this not a function because we're not one-to-one. Making this not a function because we wouldn't pass the vertical line test where each x matches with only one y. So we again restrict our domain. This time we're going to restrict it to 0 to pi, and we can write that in interval notation. So we're going to stop after this value. So let's plot our points. We have 1, 0, square root of 3 over 2, pi over 6, 1 over square root of 2, pi over 4, and 1/2 pi over 3. Then we have 0 pi over 2. Then we have negative 1/2 3 pi over 2. We have negative 1/2 3 pi over 4. We have negative 1 pi. So when we connect these, this is our inverse cosine. So we have, this was the domain of this function that we had restricted, which means that the range of the inverse cosine of x has these same values, 0 to pi. So recapping, the inverse cosine function, denoted cosine, inverse cosine of x, or arc cosine of x, is defined by y equals inverse cosine of x if x equals the cosine of y. In other words, y is the angle at which the cosine function equals x. So the inverse cosine function has domain negative 1 to 1 because our original function has domain and range. Remember that the range of cosine is negative 1 to 1, so that becomes the domain of my inverse function. And then we restricted our domain to 0 to pi, so that becomes the range of my inverse function. Alright, so now let's evaluate. If we have the inverse cosine of 1/2, we see we're looking 0 to pi, so we're looking up here. 1/2 occurs at pi over 3. Inverse cosine of negative 1, that occurs over here at pi. Inverse cosine of negative 4/3, well, that's outside of our range, so this is not defined. So let's try evaluating some expressions. We have the inverse cosine of cosine pi over 6. So first we do the inside. Cosine of pi over 6, looking at the unit circle, gives us square root of 3 over 2. the inverse cosine of square root of 3 over 2 between 0 and pi is pi over 6. And down here, first we do the inverse cosine of 1/2, and we find that that is at pi over 3. Then we find the cosine of pi over 3, which is 1/2. So cosine, remember with these, the cosine of pi over 3, this is a half because we're restricted to these values. So we can't get 5 pi over 3 because that's not in our domain. Alright, so this leads us to the cancellation that if we have cosine of inverse cosine of x, that will equal x if x is between -1 and 1. And the inverse cosine of x will equal x for x between 0 and pi. So now let's have you try cosine of inverse cosine of 1 over square root of 2, and then try the inverse cosine of pi over 6. So go ahead and pause, and then when you're ready, come back. So using our unit circle, the inverse cosine of 1/2, or the inverse cosine of 1 over square root of 2 is pi over 4. Cosine of pi over 4 is 1 over square root of 2. Down here, the cosine of pi over 6 is going to be square root of 3 over 2, and the inverse cosine of square root of 3 over 2 is pi over 6. And we could have used our cancellation that here we were between, x was between -1 and 1, so we get back the same value, and here x was between 0 and pi, so we knew we were going to get back the same x.